Hi, it's Miss Lisa from the St. Paris Public Library. Today's Anytime story is called On the Seabed.
Introduction. If all the water in the ocean drained away overnight, we would see the most spectacular landscape on Earth. Hidden world. People can only stay in the deep ocean for a short time, and so few explorers have visited the seafloor. However, we have made maps of the seabed. Without water, the ocean floor would be a vast plain. Every so often, ranges of flat-topped mountains would rise up with steep canyons cutting into their sides. In other places, there would be terrifyingly steep valleys plunging down thousands of feet. All the way down. The seafloor stretches from just below low tide level to the bottom of the ocean trenches. The deepest trenches are more than 33,000 feet below the surface. Near the coast, the seafloor gradually slopes away from the continents. These regions are known as continental shelves. They are sometimes hundreds of miles wide. Echo sounders are used to map the seabed's features hidden beneath the waves. In deep water, sailors find the depth of the ocean beneath them using an echo sounder. This machine fires a pulse of sound down through the water and then measures the time the pulse takes to bounce back off the bottom. The longer the pulse takes to come back, the deeper the water is. The world's oceans can be divided into zones. Each one has a certain set of conditions. Tidal zone, sunlit zone, deep sea zone, ocean floor. Your mission. You are going to investigate the seafloor from the shallow continental shelf to the deepest part of the seafloor. Off the shelf. The continental shelf slopes gently down until the water is about 1,000 feet deep. At the edge of the shelf, the continental slope is much steeper. At the bottom of the slope, the deep seafloor is mainly flat. Most of it is about 10,000 feet under the surface. Sunken Treasure. You will start your journey by looking for treasure off the coast of Florida. After that, your journey takes you across the Gulf of Mexico to look at the Mississippi Delta. Then you cross the Pacific and explore the Kelp Forest of California. Going deep. Moving down the continental slope, your next stop will be to look at the weird wildlife of the deep ocean floor. Then you will travel south to explore the underwater volcanoes and hydrothermal vents of a mid-ocean ridge. There you will see living things that feed on chemicals in the water. Finally, you will dive near the west coast of Mexico to find animals that live on ice. It is going to be an exciting journey. Octopuses, lobster, and starfish survive by crawling around on the floor of shallow seas. Places you will visit: Florida coast, Delta, Mississippi Delta, Kelp Forest, East Pacific Rise, and the Gulf of Mexico. Sunken Treasure. Off the Atlantic coast of Florida is a series of islands. The islands are made from sand washed up from the seabed by the ocean's most powerful storms, hurricanes. Stormy weather. The Atlantic hurricane season begins in July. In the past, most sailors would avoid long voyages at that time, but sometimes ships have to travel. On July 24, 1715, a fleet of 12 Spanish ships set sail from Cuba, full of gold and silver. The ships were hit by a hurricane. 11 of them were sunk near the Florida islands. Most of the wrecks have now been found, but a few are still hidden on the sandy seabed. You are going to look for them. Treasure hunt. The seafloor is just 26 feet down. At first, all you find is a pile of rocks. It does not look like a wreck. Then you see a rusted cannon. This must be it. The rocks are the ship's ballast, the weights carried to keep it upright in the water. All the ship's wood has rotted away, but the treasure is still there. Sand blower. A pipe is lowered from the boat. It forces out a jet of water that blasts away the sand on the seafloor. As the sand is pushed away, you see some large discs. Rubbing away the dirt, you reveal writing, and the discs become shiny gold and silver coins. An expert on board the dive boat says they were made in the early 1700s. The undersea haul is worth thousands of dollars. Underwater archaeologists have to work fast. Anything they have uncovered will be buried again by the shifting sand in a few hours. These Spanish coins were made from metal mined in South America. The gold coins were doubloons, while the silver ones were reals. In the sand. The sand on the Florida seabed is swept along by an ocean current called the Gulf Stream. Sink and settle. The Gulf Stream carries tiny fragments of rock that have been worn away from the shore. The heavier bits sink through the water and settle on the seafloor. There they form banks of sand and gravel. This happens in other coastal seas all over the world. Shifting sands. The sand banks cover the solid rock of the continental shelf and anything else on the bottom. Big storms sometimes sweep the sand away, and things that have been buried for years are exposed. This is why you found the wreck. Sample search. You collect a sample of sand away from the wreck. It contains a lot of two-shelled mollusks called clams. Clams suck water through their bodies and collect the bits they can eat. There are also worms in the sand. They eat the sand, digest any food in it, and then throw out the rest. A pair of flounders are almost impossible to see against the sandy seabed. The flat fish lie hidden, waiting for crabs or small fish to come near. Then the two fish attack. The scallops sift the sand for food. Unlike most shellfish, scallops can swim by clapping their shells together. Bacteria are very small. A line of 100,000 would stretch across your fingernail. Hidden food. Using a microscope, you can find tiny living things called bacteria and protists in the sand. They eat bits of dead animals and seaweed that drift down through the water. Mollusks, worms, and sea urchins eat the bacteria, so there is a whole wildlife community living on and buried in the sand. River delta. Some of the sand and mud on the seabed is sediment that is washed off the land by a river. You are going to take a look at one of the world's mightiest rivers, the Mississippi. Land and water. When a river's water meets the ocean, it slows down and falls to the seafloor, forming a delta. A delta is a huge fan of mud with a network of river channels running through it. River view. Why, you fly across the Gulf of Mexico to New Orleans, a city located near the Mississippi Delta. From the plane, you see a huge muddy swamp spreading south of the city. Drilling ship. You take a ship down the river to investigate the underwater delta. When you are far from land, the crew drills down through layers of mud and sand. The drill creates long cores of mud and sand divided into layers. The layers of sediment change as you get out to sea. The river drops heavier sand, but the finest mud is carried far out to sea, to the very edge of the continental shelf. The seawater around the mouth of the Amazon, the world's largest river, is full of mud for hundreds of miles out to sea. Heavy load. The layer of solid rock laying beneath the Mississippi Delta is lower than the rest of the continental shelf. It has been pushed down by the huge weight of the Mississippi's mud. Most of the Mississippi's mud is hidden under the sea. The mud covers an area of seabed that is bigger than the state of Louisiana. Scientists figure out the age of the layers of mud in a drill core by studying the fossils in them. Kelp Forest. After the muddy seabed of the Mississippi Delta, you head to California, where the seabed is very different. It is covered in a forest. In the sunshine. The forest is made of a seaweed called kelp. Seaweeds are similar to land plants. They use the energy from sunlight to make sugar out of carbon dioxide and water. This process is called photosynthesis. Floating fronds. Most seaweeds are small and grow in shallow water near the shore. California's kelp is different. It can grow to far more than 100 feet tall and grows out of the sea in the deeper water above the continental shelf. The great green fronds of the kelp are like leaves. The fronds have gas-filled bags which make them float. Rich water. The giant kelp creates a thick underwater forest for two reasons. The water is very clear, so a lot of light reaches the seabed. The water is also rich in the nutrients that are drawn up from the deep ocean to the continental shelf by the California current, which flows south from Alaska. Weedy haven. Sea anemones and crabs gather around the kelp stems. Sea snails and sea slugs glide over the fronds looking for food. Swimming through the kelp are many fish, mostly camouflaged to hide among the kelp. There is also a larger animal hiding down there. It is a giant octopus that is bigger than you are. Giant kelp is the fastest growing plant in the world. It can grow 2 feet in one day. Kelp forests provide food and shelter for many animals such as starfish. Places you will dive: Kelp Forest, East Pacific Rise. Smashing time. While you are exploring the kelp, you discover that you are not the only mammal swimming in the forest. Forest hunter. The kelp forest is the winter hunting ground for sea lions. One swoops out of the fronds as it looks for a squid, crabs, or young octopuses. In summer, this sea lion will head to the rocky shore to breed. As you follow the sea lion up to the surface, another diving mammal paddles past. This one is a sea otter. Shellcracker. The sea otter is diving to the seabed to collect a sea urchin or shellfish. After snatching up an abalone, the otter picks up a flat stone. You both head to the surface, and as you watch, the sea otter floats on its back with the stone on its chest. It takes the abalone in both paws and smashes it against the stone. Then the otter scoops out the flesh. Sea otters have some of the thickest fur of any animal. The fine hairs keep their skin dry even when they are diving to the seabed. Sea lions stay in kelp forest because they can hide there from their worst enemy, the great white shark. Super otter. Sea otters eat sea urchins that eat the giant kelp. The otters protect the kelp from attack. In places where people hunted too many of the sea otters, the sea urchins have killed off entire forests. Without the sheltering forest, storm waves rush straight onto the coast and wash away the beaches. So sea otters not only save kelp forests, they also protect the California's coast. On the edge. It is now time for you to look at the seabed in deeper water. You head to the continental slope where the sea floor plunges down into the deep ocean. Sponge reef. Your ship now travels out to sea, away from the kelp forest to the edge of the continental shelf. The water is about 660 feet deep here, and the seabed is covered in sponges. It is too deep to scuba dive, so you visit the bottom in a submersible. Dark water. Only a little light makes it down this deep. It is too dark for plants. Things living down here must catch all their food. You spot a glass sponge. Most sponges are springy, but glass sponges have brittle skeletons made from a glassy material called silica. Down the slope. When the glass sponge dies, its skeleton stays on the rock. New sponges grow on top, making a reef. The sponge reef lies beside the continental slope. This is a gentle slope with deep canyons cut into it. Its underwater cliffs plunge down for thousands of feet. The cliffs are covered with animals. For example, see-through See-through sea squirts cling to the rocks. Shoals of fish swim along the cliffs, feeding on its inhabitants. Out in the gloom you see large hunters. Squids are coming to attack the fish. Glass sponge sucks seawater through their hollow bodies to collect food. They may not look like it, but sea squirts on the right are more closely related to humans than they are to jellyfish, corals, or sponges. This computer image below shows the narrow continental shelf along the coast of South California around Los Angeles. Deep and dark. You spend the next day sailing south to the East Pacific Rise. This area of seabed west of Mexico is the start of a chain of underwater mountains that stretches to Antarctica. Long dive. You dive the submersible to the abyssal plain at the bottom of the continental slope. It takes 2 hours to reach the bottom. The seabed is a long way down, 2.5 miles below the surface. It is pitch dark in the deep ocean. The only natural light is the soft glow of bioluminescent animals that swim past. Life in the mud. The sub hovers just above the cream-colored mud of the ocean floor. At first, there is not much to see. Then you notice what looks like a bumpy slug moving across the mud, leaving a trail behind it. It is a sea cucumber. Sea floor slithers. Sea cucumbers are common seabed animals. They are related to starfish and sea urchins. If one is under attack, a sea cucumber turns its stomach inside out and squirts it out from its bottom. That is enough to scare off predators. Sea cucumbers eat the mud on the seabed and digest any food in it. They have a circle of tentacles around their head for shoveling mud into their mouth. Spider crabs search the seabed for dead fish that have sunk from the water above. Tripod fish. The seabed is home to a really strange fish that stands on 3 stilts. They are its lower fins and tail. It is called a tripod fish. A tripod fish spends nearly all its time standing like this, waiting for prey to pass. Since food is scarce in the deep ocean, the fish may have to wait a long time. Fire and water. After returning to the surface, you set off south, sailing over the East Pacific Rise. You are heading for a volcano hidden among the underwater mountains. Ripped rocks. The East Pacific Rise is a crack in the Earth's surface created as its crust is ripped apart. As the rocks split, hot lava bursts out. The lava cools into rock called basalt. This forms the underwater mountains either side of the crack. Up and over. You take the submersible up one side of the mountain to look at the crack in the middle of the ridge. The high peaks are covered with gray-brown mud. Then the seafloor gets deeper and becomes bare rock formed into strange round blobs. Young ground. The bare rock has not been on the seafloor long enough to get covered in mud yet. It must be much newer than the muddy peaks above it. This is where all the Earth's rocks come from. It bubbles out of the Earth's hot insides from cracks like this ocean ridge. In action. The submersible has reached a part of the ridge where lava is still coming out of the seafloor. You see a flash of red, and hot, thick lava squirts out like glowing toothpaste from a tube. The red turns to black almost immediately as the lava cools into one of the blobs. But then the blob bursts open and more lava squirts out of the sides, making yet another blob. These strings of blobs are called pillow lavas. Little by little, the seafloor is spreading very slowly between the two ridges of the East Pacific Ridge. In the Atlantic Ocean, this spreading effect is slowly pushing north, and South America away from Europe and Africa at the rate of about 1 inch every year. Red-hot lava erupts from an undersea volcano. It is cooled very rapidly by the water. A sonar map of the East Pacific Rise shows the mountains either side of the crack in Earth's crust. Deep heat. Ocean water gets into cracks in the ridge and is heated by the hot rocks. When it is squirted out again, the water is mixed with chemicals that feed some of the weirdest creatures on Earth. In hot water, the jets of hot water are called hydrothermal vents. You cannot see one in the dark, but your computer shows you that an area of warm water is in front of you. Suddenly, the water heats up very quickly. The lights of the submersible pick out a column of what looks like black smoke. The smoke is pouring out of a ragged-looking rock tower. Smoke in the water. The smoky water is an amazing 700 degrees Fahrenheit. It could melt the sub's plastic windows, so you keep your distance. Just a few feet from the vent, the water is a comfortable 70 degrees Fahrenheit. As the water cools, the chemicals dissolve in it, turn into tiny specks. These specks are the smoke given off by the vents. The hottest vents give out black smoke. Life support. You would expect the hot water in the vent to kill everything near it, but the black smoker in front of you is surrounded by mussels and giant clams with shells as big as footballs. Giant worms also live in tubes around the vent. They are as tall as a person and as thick as a man's wrist. Chemical diet. A tube worm has no mouth or gut, and its body is packed with bacteria. The bacteria make food from the chemicals that pour out of the black smoker. The worm supplies the bacteria by gathering the chemicals with its gills. In return, the worm feeds on some of the bacteria. Tube worms collect nutrients from the water by waving their red feathery gills. Hydrothermal vents that produce white smoke are cooler than black smokers. The vent mixes with cold water underground. Cold seep. Now that you have seen the hottest places on the seabed, it's time to look at one of the coldest. For this, you must transfer to a ship in the Gulf of Mexico. Eating chemicals. Bacteria that make food from chemicals in the water use a process called chemosynesis. The animals living around the black smoker survive on the food made in this way. Other seabed animals make use of the chemicals in ice. Salty sea. You dive 2,000 feet to the seafloor of the Gulf of Mexico. You find tube worms and large mussels, but there are no black smokers here. A sensor on the submersible measures the salt in the water. It is much saltier than you expect because it is full of a chemical called hydrogen sulfide. Frozen gas. The hydrogen sulfide seeps out cracks into rocks in the seafloor along with another chemical called methane. Methane is usually a gas. It burns in air and is used for cooking and heating. Here on the seafloor of the Gulf of Mexico, it mixes with cold water to form a soft methane ice. Places where this happens are called cold seeps. Ice worm. Just as around a hydrothermal vent, the tube worms and mussels are full of chemosynthetic bacteria. The bacteria build food from the hydrogen sulfide in the water. Some tiny worms even burrow through the methane ice. They may be some of the strangest creatures in the ocean. The ice on the seabed is called methane hydrate. It might be possible to mine this ice and use it as fuel. Despite being much colder, seeps are just as crowded with life as any hydrothermal vent. The lessons we've learned. Your exploration of the seafloor has taken you from the sunlit shallow water off the coast of Florida to the deep ocean where Earth's rocks are formed. Shallow seas. You have seen how sand and mud from continents make deep sediment on the continental shelf, and how animals live in the sediments. Near Florida, you helped discover the remains of a Spanish treasure ship. Then you explored a kelp forest on the California coast and met some of the animals that make it their home. Into the deep. Moving into the deeper water, you visited the empty plains of the deep ocean seafloor. Then you explored the underwater volcanoes and hydrothermal vents of a mid-ocean ridge. There you learned how new seafloor is made as lava pushes up from Earth's hot interior. You saw how some groups of strange animals can live on chemicals from underground. They are the only forms of life on Earth that could survive without sunlight. Sponges are perhaps the simplest type of animal. They have been living on the seabed for more than 500 million years. Some clams grow to 4 feet wide and live for more than 100 years. Old rocks. If new seafloor is made in ridges, were old rocks destroyed? To find out, you will have to dive into a deep ocean trench, such as the Middle American Trench. This is a few miles from the coast of Acapulco, Mexico, and is 18,000 feet deep. Down there is another crack in Earth's crust. Lava does not burst out of it. Instead, solid rocks are pushed down into it, where they melt into lava like magma that swirls around deep inside the earth.